Okay. Previously, we have seen how to find the transform for finite duration signals. The last class. This class, we are going to see how to determine the transform of infinite duration signal. We'll see examples. So let's start from the first example. Here, x of n is given, the discrete time signal, exponential signal, a raised to n, u of n. So let's see how to determine the Z transform of this sequence, infinite, like this infinite duration sequence. And also we are going to mention the region of convergence. As we have discussed, region of convergence, set of values of Z in which the Z transform exists, or it is a finite one. So let's see first example. So example number 1. The sequence x of n is equal to a raised to n u of n. Okay, so we are asked to find the Z transform of this sequence and mention its region of convergence. So this sequence is causal. Why we call it causal? Because a of n is multiplied by u of n. As you know, unit step, u of n has value of 1 for n greater than or equal to 0. That is u of n. So all sample values for n greater than and equal to 0, and it continues to positive infinity, all sample values are 1. Right? You know this unit step as a function of time. The sample values for the -1, -2, all the way to negative infinity, all sample values are 0. So we have defined in step previously. So if any sequence multiplied by u of n, which indicates the signal will be causal, it's only has value for n greater than or equal to 0. So let's see the Z transform. So x of z, as we know from the definition of Z transform, x of z is equal to, from the definition, n starts from -infinity up to infinity, our given sequence in time domain multiplied by z the power of -8. This is our definition of Z transform, right? So What is x of n? X of n is a raised to n as the power of n, u of n. This is our sequence. So x of n multiplied by z the power of minus n. Okay, so here u of n has value of 1 for n greater than or equal to 0. For n less than 0, u of n will be 0. So 0 multiplied by the other will be 0. So summation will be what? N from minus infinity up to minus 1 plus, let's start from n 0 up to positive infinity, right? I'm dividing u of n z the power of minus n. So as you can see from the unit step, from minus infinity up to minus 1, u of n is 0, so this will be 0. So 0 times a of n, it will be 0. So this part will be 0, right? Because of u of n. How about from 0 up to positive infinity? U of n is equal to 1. Okay. So this from 0 up to infinity, u of n is 1. So we can write this summation if n is from 0 up to positive infinity, a the power of n, u of n is 1 times z the power of minus n, right? Then we can again rewrite this summation. N is from 0 up to infinity. So we can take n common for a and z. So it will be what? A, because z is the power of minus n, it will be z the power of minus 1, the whole raised to n. I'm taking n common for a and z. Okay, now from your mathematics course, we know geometric sums. From geometric sum formula, summation any variable, let's say n from 0 up to infinity, as a power of n, a is any constant. What will be the summation from geometric sum formula? 1 over 1 minus a. If and only if this constant a, the absolute value of a, if it is less than 1. I think you remember this geometric sum formula, right? So this summation converges to 1 over 1 minus a if and only if absolute value of a is 1. If it is greater than 1, this summation will diverge. So based on this geometric sum formula, what is this summation? This summation will be 1 over 1 minus what is inside here? It is a times z the power of minus 1. This summation is equal to this, converges to this, if and only if the here absolute value of a times z the power of -1 must be less than 1. Otherwise, the summation, this power series will diverge. So if you you can rewrite this z the power of -1, you can write 1 over 1 minus a divided by z, right? Then again rewrite, multiply both sides by z, we get finally z over z minus a. So this is x of z. Z transform of our sequence, but this Z transform does exist with one condition. Here you can see the condition. This factor must be less than 1. A, you see here from our geometric sum formula, for summation n from 0 up to infinity, a raised to n is equal to 1 over 1 minus a. In this case, a, absolute value a must be less than 1. Which means if you have, let's say, x from 0 up to infinity, half the power of x. How much is this? This summation from our geometric sum formula. It will be 1 over 1 minus constant half, right? So it will be half. Why? Because half is less than 1. If it is, because it is less than 1, the summation diverges. So it's half 1 divided by 1 minus half. Okay, so it will be how much? 2 divided by 2 minus 1, 1, it will be 2. How about the summation of this power series? X from 0 up to infinity, 3 is the power of x. This sequence is converges or diverges? It diverges because here you see 3 is greater than 1. For any power series here to converge, this a necessarily must be less, absolute value of a must be less than 1. Similarly here, so this is our a here, a times z the power of -1, absolute value of this must be less than 1. Otherwise, this summation will diverge, it will be infinity. So this is our ROC, region of convergence. Region of convergence means what? Values of z in which x of z, what we have determined here, x of z exists, x of z converges to some finite value. Those values of z we call region of convergence. So in this case, what is the region of convergence? A times z the power of -1 absolute value must be less than 1. So you can rewrite this. This is a divided by z, absolute value less than 1. You can rewrite this absolute value of a less than, you can take z on the other side, absolute value of z, or you can say absolute value of z greater than, okay, this is our region of convergence. So if you put this on the z plane, as you know, z is a complex variable. So we have a z plane with imaginary and real axis. So for any constant a, so we draw a circle. This is a circle with radius A. So look here, Z must be greater than A, which means for Z must be outside this circle. Any Z outside this circle, this region, we call it Z, the region of convergence. It's called region of convergence. And if you take any value in this region outside the unit, outside the circle with radius A, is defined as our region of convergence. Okay. If Z value is inside this circle, the Z transform does not exist. Okay. Let's see the second one, second example. It's also a infinite duration signal. Example 2. So in this case, the given signal discrete time sequence is equal to a the power of n u of minus n minus 1. Okay, so minus is here, so a is any constant a the power of n u of n. This sequence is anti-causal. Why anti-causal? Because it is multiplied by u minus n minus 1. Let me explain that. So as you know, u of n unit step signal is 1, thus sample value 1 for n greater than or equal to 0. So 1, 2, 3, this is n values. Okay, for negative values of n, we have 0, right? That is unit step sequence u of n. Okay, as you can see here, there are two operations on u of n. First, shift by 1 and folding operation. When these operations comes together, we have to follow the precedence rule. So first operation we have to perform is shifting. So first, you shift u of n by 1. It will be what? U of n minus 1. Right? Shifting first. So the whole signal shifted towards the right by a factor of 1 unit. So now at 0, it is 0 because it is shifted by 1. So now the signal starts at n is equal to 1. At 0, it will be 0 because we shift signal by 1. So all these sample amplitudes 1. Okay, up to infinity. This is u of n minus 1. What's the next operation? The next operation here, as you can see, is folding. Take the mirror image of this signal with respect to the vertical axis. So u of minus n minus 1 will be, take this and reflected, take mirror image. So it starts from where? Starts from now minus 1 up to minus infinity. It goes to minus infinity. Start from 0, it will be amplitude 0 because it is folded, right? So as you can see here, when a signal multiplied by u of minus n minus 1, let's see the Z transform. So let's start from the definition. What is x of z? X of z is equal to summation from, always start from the definition, from minus infinity up to infinity, x of n, our discrete time sequence, multiplied by z the power of minus n. Okay. What's x of n? Given minus a the power of n, u of minus n minus 1 times z the power of minus n from our definition. Okay, so let me divide this summation and start from minus infinity up to minus 1 plus start from 0 up to positive infinity. Minus 1 times z the power of minus n. Okay, so as you can see here, look, the u of n minus n minus 1. All samples from minus infinity up to minus 1, they are samples 1. Start from 0 up to positive infinity, so all samples are 0. This is the characteristic of u of minus n minus 1. So what will be this? This will be now 0, because from 0 up to infinity, u of this one, u of minus n minus 1 is 0. So multiplication and the summation of all zeros will be 0. So what we have now, from minus infinity up to minus 1, what is u of minus n minus 1? This factor, it is 1. Okay. So we can write this summation n from minus infinity up to minus 1 minus n the power of n z the power of minus n. Right? Okay. Now let m, let's take another variable, is equal to minus n. Okay. So what will be this summation? Here n is minus infinity, so m will be infinity. Okay. So when, because m is the negative of n, so this summation now will be infinity. Minus 1 will be plus 1, right? So you can take the negative out, this negative here. So a the power of n means minus m, minus n means m, z the power of positive m. Just I substitute m minus n by m, because this summation from minus infinity up to minus 1 becomes from positive infinity up to positive 1. Okay. Now we can write again this summation m from infinity, from 1 up to infinity. Take m common. It will be a the power of minus 1 z. I'm taking m common. Okay. Now again from our geometric sum formula, if you take any variable x from 0 up to infinity, a raised to x, what is the summation? Summation 1 over 1 minus a, if and only if absolute value of a less than 1. Right? This is geometric sum formula. This summation starts from 0, right? But in our case, m starts from 1. So when x is 0, we can write this summation as when summation when x is 0, it will be a to the power of 0 plus, now summation you can start from 1 up to infinity, a raised to x, which is equal to what? 1 over 1 minus a. Here it starts from 0, so I substitute 0 value here, so x summation starts from 1. What is a raised to 0? It is 1. So what will be summation x from 1 up to infinity a raised to x? It will be 1 over 1 minus a. Take this on the other side. A raised to 0 is 1, so we substitute 1. So what will be this? It will be a divided by 1 minus a. We derive this from the geometric sum formula. Okay, so but you have to keep in your mind for this power series to converge, the absolute value of a must be less than 1. If it is greater than 1, our power series will diverge. So what will be the summation then? You can see here, this is now our value. So summation now m from 1 up to infinity will be a divided by 1 minus a. So minus 1 z divided by 1 minus z. Here we have the negative from here. Okay. So this summation will be because of the negative, z over z minus a. You can factorize this, multiply both sides by a, then here we have, don't forget the negative here, so we get this much, z over z minus a. This is our Z transform, x of z. Okay. Now the next one is region of convergence. So this summation to be converged, what is the condition? The condition is absolute value of a minus 1 z must be less than 1, right? Which implies absolute value of z must be less than absolute value of a. This is our region of convergence. It is now less than a, right? So if you draw the z plane and a circle with radius a, what will be the region of convergence? All value of z less than a means inside this circle. Inside the circle. So here is region of ROC. All value of Z inside the circle make Z transform exist. If you take any value outside this circle, any value of Z, Z transform does not exist. That's the meaning of region of convergence. So in the first case, we have seen example for causal sequence. So this exponential, this a raised to n multiplied by u of n, which makes it right-sided sequence. So for right-sided sequence, the region of convergence is outside the circle. Outside the circle. Inside the circle, the Z transform does not exist. For second example, we have taken anti-causal signal sequence, which means left-sided sequence. It is infinite length, left-side sequence. We have determined the region of convergence is inside the circle. Okay. All value of Z, what is Z? Complex frequency, right? So these complex frequency variables inside the circle make our signal, our transform exist. Outside the circle, the Z transform does not exist. That's what region of convergence means. Okay, let's see the third one. Now the given sequence x of n is equal to a raised to n u of n plus b raised to n u of minus n minus 1. So here clearly you can see the first part is a causal sequence because it's multiplied by u of n. Here you can see second part is left-sided sequence because it's multiplied by u of minus n minus 1. Now we are asked to find the Z transform of this sequence. So x of Z will be, always start from the definition, n from minus infinity up to infinity. The signal x of n times Z the power of minus n. This is our definition, right? So summation n from minus infinity up to infinity. What's x of n? A raised to n u of n plus b raised to n u of n minus 1. Sorry, minus n minus 1. The whole multiplied by what? This is our x of n given time multiplied by z the power of minus. This is the definition. Okay. So now we can rewrite this. Summation n from minus infinity up to infinity a raised to n u of n times z the power of minus n, the first, plus summation n from minus infinity up to infinity. What's the next one? This times this. So b the power of n u of minus n minus 1 times z the power of minus n. Now, from our first example, if your signal is causal, right-sided, multiplied by u of n, as you can see here, the summation starts from where? Starts from 0 up to infinity. Okay, because u of n is 0 for negative values. So it will be a the power of n, z the power of minus n, plus, how about this summation? Because it is left sided anti-causal signal, n starts from minus infinity up to minus 1. For 0 up to positive infinity, it will be 0. Okay, so in that case, b the power of n, z the power of minus n. Okay, so for our first example, what is this summation? What is the transform of the first one? Z over z minus a, right? Plus, how about this one? From second example, it will be z over b minus z. Okay. Now, for the first one to converge, the first one, for this summation to be here, what is the condition? The condition, absolute value of z, we have discussed in example 1, must be greater than absolute value of a. Second one, for this to diverge, second example we have discussed, and it is end. Absolute value of z must be less than b, right? So it is the intersection. So you see, this is the Z transform. X of Z is here. Is here. How about the region of convergence? Region of convergence. Now we have two circles. The first one with radius A. Radius A. Second circle with radius B. So this is radius B. So you see the first one, it must be outside the circle with radius A, outside, and the second one, it must be inside radius B. So what is the intersection region? This is the intersection because it is end, right? It is end, not or. So this region where this region, our ROC, will be what? Absolute value B must be less than Z, right? Z must be greater than A. Sorry. No. A must be less than Z, absolute value of Z, and absolute value of Z must be less than B. Less than B. So this is our region of convergence. The ROC. Only the values of Z in this region makes this Z transform of this sequence exist only in this region. If you take any value of Z outside this region, the Z transform does not exist. Okay. See you next class.